Today, we have Benjamin Baumann joining us. Ben is a Senior Staff SDE Lead at Criteo and has been with the company for several years. Ben has played a pivotal role in shaping the engineering culture and best practices at Criteo. So I want to ask you, given your extensive experience, what advice, like in general, for software development would you give to juniors and newcomers?
Lots of pieces of advice here. I think that I can think of two that to me are the most important. So first, you will get lots of advice on the internet, and usually they are really good. The two ones that I want to focus on first is be curious. Go always one more step. When you work with product, get to know the product you are building, get to know your clients, get to know how your product manager is working, why you are building this project. If you understand this, you will be able to connect, you will be able to speak with your product owner and product manager and to propose alternative ways of doing things that makes more sense technically while still fulfilling the feature request. It works also on the other side. If you use an external API, if you use a SDK, okay, get to know them. What are their constraints? What are they built for? And it will help you get more insight on the system your application is part of. And the more you know the system, the more skilled you are to propose a good solution to a problem. And sometimes it's not adding code and feature in your application. Sometimes it's using an alternative application or changing the spec. This is really something that I learned with experience, and I think it's really worth stating and sharing with people. Software developers, for sure, we develop, but we are also engineers usually that are proposing solutions to problems, and that's one way thinking about the system.
So being curious about product and about the system, right? Like to summarize.
Yeah. Be curious, go one step further. When someone is asking you something on your application, why? Ask why and understand how they are using it. If you understand your client, for example, if you build an API, and if you know your clients, you may get more ideas of which feature could be useful for your clients.
Yeah, I definitely agree. And you said second one?
Yes. Second one is about people. Usually a cliche, which is sometimes true, but MIT teams, it's just a bunch of people arguing with each other. And as I said, it's usual when we are building a new team. At one point, we have a storming phase. People are arguing about things. If you know the people, if you know Paola, if you know Alejandra, if you know Yosha, Ida, if you get to know them, it's much easier to communicate. It's much easier to go over badly written phrases, sentences that could be felt like blaming, and it's much more efficient, and more than efficiency, it's much more comfortable working with people you know, you value. So things like egoless programming, egoless code reviews, connecting with people. If you value people and get to know them more, it will be much simpler to have technical discussions.
Yeah, I totally agree. I really think the interactions change when you start knowing your teammates, and they become your friends even. It's really great.
And that's something we tend to forget because we are working with computers, we are writing code that is executed by computers. So we tend to forget about the people that will be reviewing the code, that will be reading it, that will be using it. But yeah, software
Yes.
development is also about people.
Yeah, I totally agree. Thank you, Ben. Your advice is like incredibly valuable. Now, let's transition into our deep dive session where we'll explore effective testing strategies and patterns. Shall we?
Yeah, let's do it.
Okay. In my previous life, when I was a researcher, I worked on a project that started as a prototype. So at the beginning, it was very easy to develop. We like added a feature, we ran the app, we checked manually to check everything was working as expected. But you can imagine as the code base grew, every time we added something, something else break somewhere. And we tried to like manually check, but like it was impossible. So it felt like this cat and mouse problem. So it was very challenging. And at the time, I remember that at university I had some lectures about like testing, and I remember, oh, this was not only theory; it has some like a practical like value. So yeah, then I realized of the importance of testing. So yeah, of course, like knowing testing and adding testings from the beginning could have saved us like so much time and frustration. So testing is important in software development. From your point of view, why is testing important, especially at a company like Criteo?
Yeah, and first of all, I think most people in the audience working on R&D software development, they could definitely relate to your experience. I can definitely relate to it. The famous production, the prototype that goes into production and that needs to be maintained afterwards. Yeah. So testing. Testing, to me, it's important to first validate, accept a feature. This is what it needs to do. This is what it does. And we agree. That's part of the contract. That's what we build. But most value of the test from me goes through non-regression testing because that's a contract. That's what we build. And if it's an automated test, it will be run regularly and it will remain the same over time. So 6 months later, it will still be part of the software contract. I have this feature, it's tested automatically, and it works. I like to say that test is like cement. You can build a wall, but if you don't have any cement, it may crumble at one point. If you make a change or if someone buys a house and want to remove one stone, it may crumble. If you have cement, the buyer won't be able to remove this stone. On the other side, if you bring too much cement, you won't be able to break a plasterboard. So you won't be able to change anything in your house. You won't be able to change the furniture. So that's what happens when you are doing when you are adding too much cement and when you are adding too many tests. Yeah,
That's a
tests.
great analogy. I
Yeah,
love it.
I really love this one. Test, that's cement, that's an insurance, that's what you built is doing what it should, and that it will continue to do it in the future.
And in a company like Criteo, because Criteo is a large company, let's like 1,000 developers, I think. So how like what role testing plays in a company of this size?
It's a requirement. I mean, we have so many developers, so many projects. You cannot, if you don't do test, usually, okay, I'm alone on a project, I'm the only one. I don't need test because I don't want to pay the cost, initial cost. I don't do documentation as well because I am the documentation. And it works okay until you stop your project for 6 months and go back to it and, oh, what was this supposed to do? If you are in a big company with big projects, lots of teams, you really need this test. Otherwise, no one is understanding what how things should behave.
Yeah, I totally agree. And like I think there's a balance between automated and manual testing. I think automated testing is great for covering like a lot of ground quickly and consistently. But manual testing, I think that it has some value. For example, for front end, like it really helps us to dig into the user experience and catch some issues that scripts might miss. How
Yes.
do you decide? Do you have some advice on this?
I tend to agree with what you said. To me, whatever is about non-regression testing should be automatic. That's a cement. That's something you don't want to break, to change. Manual testing, to me, it's fine when you are either exploring the feature, so the specs are not really clear, or you are making the specs. Okay, what should I do? I'm playing with the solution, with the mockups, and trying to see how the system should react. So that's part of manual testing for me. One case that you mentioned is about front-end testing when you are doing something manual. To me, the limit is when you are testing feature, what it should do, and implementation details, how it is done. Or I could say, implementation details or exceptions. This is not part of the feature. Sometimes in specifications as a functional or technical specification, not everything is specified. And when you are coding, you will make a choice. Okay, this is not in the spec. I will raise an exception, or I will return false, or I will log something. This choice is not something you want to test because that's not part of the feature. Maybe the test could be, okay, I don't want my application to crash suddenly, but that's a technical spec for your application. These choices usually are best when tested manually.
I see, makes total sense. And yeah, I don't know if you want to add something or I was thinking on automated testings. Sometimes we want to like cover everything, like we want to be sure that everything is tested, and this is when test coverage like comes into play. So test coverage measures how much of your code base is actually being tested, but sometimes it's not only like hitting this measure, like having this like 100% test coverage. How do you make sure that tests are meaningful, and what do you think about test coverage?
Yeah, test coverage. That's a big question, and I guess lots of people will have different point of view. The first thing, with my experience, I saw several times code coverage being used as a target. You should reach 80%, 90% of code coverage. And it works most of the time, but sometimes you will have teams, individuals gaming the system. For example, you write a test that doesn't assert anything. It will go through the code and say, hey, I'm increasing my test coverage, but you are not increasing your software quality. You are not adding cement. You are just writing code that is going through code. So yeah, like any measure, it can be gamed, but still that's useful. It's best to have an incorrect measure rather than to have no measure at all. That's not science. That's one take that I do. And test coverage, it really helps you. Yeah, for example, when it's okay. It's a trade-off. Let's say you have code that is not needed. If you are looking at code coverage, you have two options. Either you remove the code and you increase code coverage because you have less code, or you write a test on this code that is not used, which will also increase code coverage. So it's a measure. It's not a way that will always enforce you to do the right thing. My tips for code coverage would be to use it not as a target, but as an indicator on legacy code base, for example, saying, okay, we have a rule. We set a rule as a team on this repository. Every commit should not decrease the code coverage. So we want all new code starting from now and refactorings to include test. So we are not gaming the system saying, hey, we should reach 90% when we are at 30, but it will be small improvements, small steps. One other idea is when you start to do code coverage targets based on features and not on code. One idea could be, okay, every entry point of your application for the happy path should be tested. So usual case of your application, of your REST API, every endpoint on nominal condition, this should work and this should be tested. That's the cement you want to have. That's the features you want to support for your application.
You've talked about legacy code, and we know like legacy codes can sometimes be a black box, and you don't know these features. Like they were known at some point, but now like they are lost. So how do you approach like testing legacy code? Or because when you have to make a change, and sometimes you have to make a change in some critical legacy code, like it's very risky. How do you have strategies to handle these situations?
Yes. And first thing, I want to piggyback on what you said, critical legacy code. Usually legacy code is critical. If it is not critical, it would not be a bother. Okay, that's just old code. Let's remove it. But legacy code, hey, it's in production, it's running, it may be complex. 3 different teams owned it over time. And yeah, that's where we stand. It's not a fatality. Every code becomes legacy at some point before it is deleted. My tips for testing legacy code would be to really do black box testing. So black box means, okay, I have this box, which is my application, that's code, and I don't know what's inside, and I don't even want to know. That's just a system I can interact with and get something back. And that's what black box testing is, isolating this legacy box system and testing the features. This works only if you know the feature the system should support. If you don't have spec for the feature, worst case scenario, what you could do is say, okay, I have a box, I can feed it input and I get outputs. And say, okay, it's critical, it's in prod, it works. Let's postulate that it works. And you can start adding test acceptance. This is called acceptance testing, saying, okay, I'm randomly giving input to the system. I'm observing output, and this output becomes the assertion. And the contract is starting now. This becomes the technical specification. This is a contract. This is a cement. I don't want it to change.
That's very interesting. Acceptance testing, yeah, I think it's very valuable. Changing a bit of subject, there's another interesting debate in software community, and it's around dump and dry. Dump stands for descriptive and meaningful phrases, while dry stands for don't repeat yourself. So dry aims to reduce redundancy, and dump suggests that some repetition is acceptable. Of course, if it makes the code more understandable. And I've heard you talking about dump versus dry in the context of testing. Can you give an example of where would you apply dump over dry and why?
Yes. So as you said, dump stands for descriptive and meaningful phrases. And to me, that's really important because a test is something that will be run automatically, something that you write once, but that will be read several times by human beings. If at one point the continuous integration system tells you this test is read, what's most important for the people looking at it is understanding what the test is doing, what is broken. And if you are using descriptive and meaningful phrases, if you are using dump, it will be easier for this person to understand what is broken. It's definitely possible to have convoluted, complicated setup system for test with inheritance, setup, hooks, and have tests that are only doing assertions. Okay, I'm asserting this, but when you are reading this code, say, hey, what is the test doing? You have to go back through several class, know that it's about, oh, that's that's a one-time setup, that's a setup, that all this make it complicated. If you are using dump, even with a mix of dry, this kind of test would be, hey, I'm arranging the data, the system in the first step. And in this step, I may be using dry, using builders, for example, instead of having tens and tens of lines of new data, new entity with so on and so on, which is not about what the test should be doing. That's not meaningful. These are details. What is meaningful is, okay, I want a valid campaign. This is both dry and dump. It's descriptive and meaningful. Give me a valid campaign, and I store it in a campaign. I don't have to wonder about what it means to be valid. It's here. And it's dry. I'm not repeating myself. That's a builder I can reuse in other tests. Once you have this arrange part, then you act on your system and you assert. That's really the big part. Be descriptive in your method calls, in your test names, in your builders, so that if I read the contract is, if I read the test method code, I should understand what it does.
That sounds great, because yeah, as you said, sometimes the test is failing, and no, like even not failing, you just want to understand what the test is doing, and there are like 50 lines of mocks and you get lost. Yeah.
Yes. And let's face the truth. When something needs to be changed in these 50 lines, usually it's not changed. The mock is still here. It saves nothing. It's just dead code.
Yeah, yes. And moving to a more technical aspect, let's talk about system boundaries. So when dealing with complex system, this is a crucial concept. System boundaries help define what's in scope and what's not. And this is, I think, very important for testing. In practice, however, I found it sometimes hard to keep the boundaries clear, especially when you are like changing a test that already exists. Sometimes you just want to make your change and go on with your life, but this is like not well defined. So how do you keep these boundaries clear? How do you handle like testing interactions with the internal system and external components?
Yes. And there are two ways we could understand your question. First one is, okay, it's about boundaries, that's for sure. But what is a system? Usually when you are testing, the smaller part is unit test, and a unit has also a boundary. What is the boundary of your limit, of your unit? Is it a class? Is it a group of class? And even this small question is triggered a lot of arguments over the past decades between the mockist, the London School of doing unit test, and the classicist, Detroit School of doing unit test. Basically, you have two solutions. Either your test is more solidary, you are testing several classes together, and this group of class together is a unit, a system, or you want to have a smaller system and it is everything that's outside of your system is mocked, stub, fake. We have some technical things that can be substituted to the read implementation and act on behalf of it. For system, that's the same thing. When does my application end? Is it at the database layer? Is it in pre-prod when everything is connected? several options are possible. Usually, what we do at Criteo is having unit test, testing units in the code base when it's complicated and when we have business logic that needs to be tested. And feature testing are tested usually in isolation. And what we call by isolation, that's our application in addition to private storage. So we are ensuring that our application outside of external application is working as expected. And at the boundaries, we are using fakes, usually, which are substitute to the real clients for other systems that behaves the same way.
And I'm curious, like all like these keeping system boundaries and all of the other practices that we mentioned, like are like good practices for testing. But how do you ensure that these practices are applied like within your team and in different teams at Criteo? Do you have any advice to make sure, like, to ensure consistency?
It really depends on the company. It depends if you have governance teams that say, hey, it should be done this way. Criteo is given much more power to developers to choose the right thing. But the risk is that everyone is doing things a bit differently or not applying. And in the case of test, that's really important because you had the chance to have lessons at university on test, but that's at least when I was in school, that was not common. Or what I learned was, okay, tests are important. We need to have tests, but how to test efficiently was much more lessons hard learned than theory.
But I think it is like that for even if you had like lectures, it was just a lecture that I studied. Then you like I think you really learn like through experience.
Definitely. And I think what is important to enforce this good practice is first state them. There need to be good practices somewhere. Written in Criteo, we have a testing strategy. Say, okay, these are the good practices, patterns that you may use, and what is important. Code reviews are also a good way to share good practices. Hey, you missed one test. Oh, you did this test this way. Maybe you could use a theory or a property-based testing, or did you know about spec flow tests? That's one way to trigger discussions. And what we are doing right now, speaking on Zoom for public communication about testing, sharing knowledge, that's a thing. Could be through video, Medium post, internal to the company. Could be through conference doc, any place that the company have to share technical tips, tribal knowledge, presentation, beer and tech. Use it to share best practices. And even best if you can have a panel and several people talking together about, hey, you are senior, you are junior. What do you know about test? What did you learn in your experience?
That
I really
sounds
think that's where we have the most value when sharing.
yeah, I totally agree. That's why we are doing this, as you said. Before we conclude, I'd love to know if you have any final advice on testing.
Um, Need to choose.
Yeah,
I would say the most important is to think of the cement. That's testing, that's really cement. That's how you want it to build it, and how you want it to survive over time. And for this, if you think about cement, you will be, okay, I will test maybe features and not the code. I need to have light Maybe it's not one window, maybe it will be a door with a window, but I need to have lights. That's a bit of difference between feature and code. And the second one, because I failed to choose, is to not over-test. If you test too much, you will cement what does not should be cemented, and it will be a pain. When you are doing a refactoring, when you are changing your house interiors design, your test will be broken when you didn't change any feature. This is not how it should do or how it should be. Tests should be helping you, giving confidence that nothing will break. If the first thing that breaks when you are doing test, when you are doing refactoring is test, usually that's not a good start.
Yeah, I agree. And yeah, I don't know if you recommend any resources or like for like people that want to learn testing, or like a way to practice or to learn how to test. Do you have some advice on that?
Yes. So first, try regularly to do test first. I said test is cement, and usually we are putting cement in the end. But doing tests first, writing what your feature should do, and then doing code. When it works, it's really awesome because you will be writing code only the code only which is useful to your feature. You won't add any extra code. You will have close to 100% of code coverage and feature coverage. That's a good one. You are not writing code that you don't use. No more YAGNI, you ain't gonna need it because it's not part of the feature of the test. So that's a bit of a mindset to get when you are building a feature, but it's really, really useful. So try it. There are multiple resources on the internet. Kent Beck, who is a long timer in the industry. He was part of, so he's the father of TDD and was part of Extreme Programming as well. He's really a good source of knowledge. I won't say lecturer because he usually doesn't give lecture, but brain peak and small articles that he can do, books are really, really nice.
Thank you. Thank you for those insights, Ben. That was really, really helpful. We've covered a lot of ground, from understanding the importance of testing, learning about managing system boundaries, handling legacy code, and like be better developers and people like in our work. Thank you so much, Ben, for joining us and sharing your expertise.
Thanks, Paola.